Hello friends, here in this video we will see a problem on design of shaft. For that purpose here we have the question. Let's read what is given here. A line shaft is driven by means of a motor placed vertically below it. The pulley on the line shaft is 1.5 meter in diameter and has belt tensions of 5.4 kilonewton and 1.8 kilonewton on tight side and slack side of belt respectively. Both these tensions are assumed to be vertical. If the pulley be overhang from the shaft, the distance of the center line of pulley from the center line of shaft is 400 mm. Find the diameter of shaft. Take tau, that is shear stress, as 42 megapascal. Now this is the question which we have based on design of shaft. Whatever is given here, we will write that in the form of data first. So let us get started. Whatever is given, I'll write that in the form of data. Now, a line shaft is driven by means of a motor placed vertically below it. The pulley on the line shaft is 1.5 meter in diameter. So the diameter of pulley is given. The first thing which we have is diameter of pulley. I'll write down it as capital D, and that is 1.5 meter, or we can say 1500 mm. Next, and has belt tensions. Here we have to remember, see both the values. This one is greater, that is 5.4, and here the value is less, that is 1.8. So always the greater value will be the tension in tight side. It is given that 5.4 kilonewton it is on tight side, 1.8 kilonewton it is on slack side of the belt. So tension on tight side has more value. So I'll write down this as T1, that is tension on tight side. It is 5.4 kilonewton, and that is equal to 5400 Newton. Tension on slack side it is given as 1.8 kilonewton. So it is 1800 Newton. Next, both these tensions are assumed to be vertical. Now, if the pulley be overhang from the shaft, here the condition is given, and the distance of the center line of the pulley from the center line of the shaft is 400 mm. So the condition is, I can explain it with a diagram. Here we have a pulley. Next, I'll draw it in a very simple manner. Here it is given that the pulley is supported at one end and it is overhanging from the other end. So here is the diagram, and the distances are given in this problem, that is the distance from this center where the shaft is supported to the center line of the pulley, that is taken as 400 mm. This is the pulley, and here when I look from this side, this shaft would be hidden and it would be here. Now in the question it is given that both these belt tensions, they are vertical. So that belt tensions, I'll show them as vertical. These are the tensions T1 and T2. These are my directions. Now take tau as 42 megapascal. Tau means shear stress, that is 42 MPa. It means it would be 42 Newton per mm square. And for this case, we have to calculate the diameter of shaft. Here I'll denote diameter of shaft by small d, and capital D would be for the pulley. So this much is the data which is given for this problem. Now, as we look into this problem, shaft is a rotating member, so it would be constantly rotating. So when the shaft rotates, there is some amount of torque, or we can say torsion or twisting moment. So this shaft would be twisted. Next, here we are having a pulley which is overhanging from the shaft. Because of this pulley, what may happen is that since one end of the shaft is fixed, this is the bearing, the other end is overhanging, there are chances of this shaft to bend because of this pulley. Now, the weight of the pulley is not given in the question, but they have given us belt tensions. So from these belt tensions, we can get the amount of weight acting here. So I'll denote capital W as the weight which is acting here. So with these data available, let us try to get the solution. I'll say that since the torque transmitted by shaft is given by, now whenever we have belts in the problem, that is belt tensions, tension in tight side and tension in slack side, in that case the torque formula is T is equal to tension in tight side minus tension in slack side multiplied by the radius of pulley. This is the formula. From this we can get the amount of torque which is transmitted. So therefore I'll say that capital T is equal to T1 is 5400, T2 is 1800. Now the radius of pulley, diameter of pulley is given as 1.5 meter or 1500 mm. So here the radius would be 1500 divided by 2. So from this I will get the value of torque, and my answer is 2700 into 10 raised to 3 Newton millimeters. This much is the amount of torque which is transmitted by the shaft. Now I will say that also total load because of belt tension, that is capital W, it will be equal to T1 plus T2, because as we can see in the problem, the weight which is acting, it is nothing but the weight of the belt tensions on both the sides. So therefore I'll write it onto the next page. W is equal to tension in tight side, that is 5400, tension in slack side, that is 1800. So from this I will get my answer of W as 7200 Newton. So this much is the weight which is acting on the overhanging portion of the pulley. Now once I have this weight, I can say that here is the bearing. The shaft, I can explain it with just a single line. This represents the shaft, and here we are having this total load of 7200 Newton. its length is known to us, it is given, this distance is 400 mm. I'll say that at this bearing I'll consider it as point A. So what may happen is that because of the load acting, this horizontal, this shaft, it can bend, and bend, like for example, like a cantilever beam, it can bend in this way. This is the bending of the shaft. So I'll say that now, since bending moment acting on the shaft, that will be moment at A is equal to, I'll write it as M, and that is W into 400. So it is 7200 into 400. So from this I'll get my answer of M, that comes out to be 2880 into 10 raised to 3 Newton millimeters. So this much is the amount of bending moment. Previously I have calculated the amount of twisting moment, that was torque. Now I have bending moment. After this I can say that therefore the shaft is subjected to both twisting and bending moment. So for that we can say that therefore equivalent torque, that would be given by T equivalent is equal to square root of T square plus M square. So this is the formula of equivalent torque. In this I'll put the values which I have got. So therefore T equivalent will be equal to square root of T square. The answer of T which I have, T was 2700 into 10 raised to 3. So 2700 into 10 raised to 3 whole square plus bending moment I have got just now, its value was 2880 into 10 raised to 3. So from this I will get equivalent torque, and that is 3950 into 10 raised to 3 Newton millimeters. Once I get equivalent torque, I can say that also this equivalent torque, and since in the problem only shear stress is given, we can go into the data. Yes, here as we see only shear stress is given, so we would be designing the shaft based on only equivalent twisting moment. So therefore T equivalent is pi by 16 d cube into tau. This formula I can say that it is by strength criteria for shafts. This formula has come from the strength criteria. Now in this I can put all the values. So therefore the value of T equivalent is 3950 into 10 raised to 3 is equal to pi by 16 d cube into tau value. It is given in the problem as 42 megapascal, and that is 42 into, it is 42 Newton per mm square. Now from this what I will do, I will keep d cube on one side, shift this 16 onto the other side, pi into 42 would be in this denominator. So from this first I will get the answer of d cube, and then if I take the cube root of that answer, I would be getting the value of D as the answer which I have here, that is, it comes out to be 78 mm. And see, for shafts, it is the diameter should be in a proper range. Like if the diameter range is from 25 mm to 60 mm, then there is steps of 55 mm, means we have to select the next higher value. And after 60 mm, from 60 mm to 110 mm, the steps are of 10 mm. So 78, it lies between 70 and 80 mm. So it is better to select the next higher value, and that next higher value is 80 mm. So this is our answer, and the meaning of this is that here we are having a shaft whose external diameter would be 80 mm for the given conditions, that is, for the amount of power transmitted as they have given in the question, for the amount of tensions there on this pulley, the shaft diameter should be 80 mm, then only it would be resisting all these values. And with this we have designed the shaft in this video. I hope everything is clear.